in solid evidence, we should be able to review double replacement reactions. We also call them double displacement reactions. We should review forming ionic compounds correctly. We should also be able to identify a precipitate based on what the reactants are, and also understand balanced equations represent mole ratios, the coefficients that is. Moving on, a precipitate is a solid formed in a reaction. And normally we're going to consider this from things that are in aqueous solution. So we'll notice that potassium chloride and lead nitrate are an aqueous solution in this case. And we form a solid in another aqueous solution. Now, this here is called the precipitate. Oops. This here is the precipitate, abbreviated PPT, because we see that it forms a solid. And this here is what we call the supernatant. Abbreviate that SNT, because it's what's left over. So key things are two aqueous things in aqueous solution come together, forming a solid and a supernatant. So moving forward. Now we talked about solubility in terms of quantitative, how soluble something is. Now we're just going to go a little simpler and go to qualitative. If a substance has a high solubility, we consider it soluble. If a substance has a low solubility, we consider it insoluble. And what we're going to have here is we're going to have a chart. So we consider something like, in this reaction, we consider PbCl2 is insoluble because it's a precipitate. So we have PbCl2 is insoluble because it's a precipitate. And KNO3, PbNO3, and KCl are soluble because, well, they're all in aqueous solution. Those are considered soluble because they will dissolve. Moving forward, we have this chart here. It's a solubility table. Notice that S here is soluble and N is not soluble. It's important to pay attention to the key. So if we look up where we have lead right here, lead is right here, and we look at chloride, this is the anion, they come together here, an N. And N means not soluble. Not soluble means forms precipitate. That's what N means. N means it forms a precipitate. Okay? So it's good to pay attention to what the graph actually says, or the table says. So let's for a second see what happens. If we mix potassium iodide, Ki, right here, aqueous, with lead nitrate aqueous. So first we write our reaction. We have 2 Ki plus PbNO3 forming KNO3 and PbI2. Now these are the possible precipitates. So let's see, it's going to be either KNO3 or PbI2. One of the two is going to be your precipitate here. So what we do is we go on and let's take a look. I actually have a video here of what happens. So first we see our lead nitrate. And then we see our potassium iodide. And first added is the potassium iodide. Notice how a little drip gets dripped on up here. And then I mix them together, and you see a bright yellow precipitate forming. It looks like a cloudy, milky mixture. And that's what we see there. Now that is the compound that forms is one of those two substances. So, move on. Let's try to figure out what that was. It's one of those two. It's either, so let's look on this chart and see what our possibilities are. We have potassium, which is here, potassium nitrate. Let's see what potassium nitrate says. We see S. S meaning it's soluble. So that is not our precipitate. S meaning soluble, not precipitate. Now let's take a look at the other one. Let's not just use process of elimination. We have lead right here and iodide right here, lead iodide. And we consider this right here, not soluble. N means not soluble, and that means it's our precipitate. It is our precipitate. So moving forward, we used that table to predict it that it was, so we figure out that KNO3 being aqueous and lead iodide is our precipitate, our solid. So we're going to be using these tables to determine this. So they're pretty simple, but just make sure you're paying attention to things like what the key says versus what's written in the reaction. And that's it.